Hello all, welcome to the next subtopic of electrostatics, and in this session we are going to learn about the numericals, the unsolved problems which are there in our textbook. So starting with the first question, two small spheres, five two small spheres 18 centimeter apart have equal negative charges. So what is the data given? So there are two small spheres. Suppose this is sphere 1, this is sphere 2. They are separated by a distance of 18 centimeter and they have equal negative charges. Suppose this is of minus q, this is again of minus q. Obviously, because of the same charges, they are having a repulsive force. They are repelling with a force of, so the force is also given 6 into 10 raised to power minus 8 Newton. Find the total charge on both the spheres. So find the total charge means q1 plus q2 we want to get. This is the value of q1, this is the value of q1 suppose, this is the value of q2. So data, what is the data? q1 it is equal to q2, it is equal to minus of q. Both are having equal and negative charge. Have equal negative charge. It is written in the question. Force is given 6 into 10 raised to power minus 8 Newton. Okay, and the distance between them is given. The distance between them is 18 centimeter. We can say it is 18 into 10 raised to power minus 2 meter. What is to find is find the total charge. Total charge means Q1 plus Q2 is to be calculated. Q1 plus Q2 is to be calculated. What is the formula that we are going to use? We will be using the simple formula of Coulomb's law. F it is equal to 1 upon 4 pi epsilon 0 K. Now since K is not there, it is not given what is the value of dielectric constant, we will not write K. Okay. We will assume that K value is equal to 1 multiplied by Q1 Q2 divided by R square. This is the formula. So by this we will be calculating first Q and then what is the total charge? The total charge is Q1 plus Q2. Q1 is Q, Q2 is again Q. Solution. F value is given to us, it is 6 into 10 raised to power minus 8, while 1 upon 4 by epsilon 0 we know it is 9 into 10 raised to power 9. Q1 into Q2 both are negative minus Q into minus Q divided by R square. The value of R is 18 into 10 raised to power minus 2 the square. Okay, so therefore what is the value of Q square? Q square it is equal to 6 into 10 raised to power minus 8 into 18 into 18 into 10 raised to power minus 4 divided by 9 into 10 raised to power 9. Okay, so we have to solve this. You have to solve this and get the value of Q. Okay, you will get Q in coulombs. Obviously you will get the Q value should be negative, and if suppose you want to find Q1 plus Q2, then Q1 plus Q2 what it will be? Q1 plus Q2 is nothing but minus Q1 minus Q1, that is nothing but minus of 2Q. Okay, so Q value you have already calculated, just multiplied by minus 2 you will get the total charge on both the spheres. Okay, so this is your homework. Please do these calculations. Okay, and do message me if you are having problems in the calculations. Let us move to the next question. The next question says a charge plus q exerts a force of minus 0.2 newton on the another charge minus 2q. So there is one charge plus q and there is another charge minus 2q. If they are separated by this much distance, 25 centimeters the distance, determine the value of q. So there will be an attractive force. Okay, the force of magnitude is what? The force of magnitude is minus 0.2 newton. Negative force indicates it is attractive. Negative force indicates it is attractive. So what is the data given to you? The force value is equal to minus 0.2 newton. Okay, q1 value is equal to plus q. You can say q2 value is equal to minus 2q. Okay, q1 value is equal to plus q. Q2 value is equal to minus 2q. The value of r R value is 25 centimeter. We can say R value is equal to 25 into 10 raised to power minus 2 meter. Okay. So this is the force and Q and R. What we are interested in getting the value of Q to find is F it is equal to 1 upon 4 pi epsilon 0. Again K is not there. We will not write K. Q1 Q2 divided by R square. That's the this to find is Q. Okay, and formula we are going to use is this is the formula what we are going to use. Okay, let us move to the solution part. F value is known to us, it is minus 0.2. This 1 upon 4 pi epsilon 0 value is known to us, it is 9 into 10 raised to power 9. Into Q1 is Q, Q2 is minus 2Q divided by R square. R square is 25 into 10 raised to power minus 2 the whole square. So this is equal to minus 0.2, it is equal to 9 into 10 raised to power minus 9. And q and minus q again it will become minus. So this is going to be 2q square divided by what? 25 into 10 raised to power minus 2 the whole square. Okay, so negative sign will get cancelled, minus sign will get cancelled. This 2 value will get cancelled, this 2 and this 0.1 it will become 0.1. 0.1 it is nothing but 10 raised to power minus 1. Okay, so just calculate the value of q. This is what q square is there. You have to take square root. This is very simple calculation. 25 already is there in square, so it will become 25 only. It will remain 25 only. The value of 9 will be square root is going to be 3. Okay, and 10 raised to power minus 9 have to be solved by using this 10 raised to power minus 1 term. Okay, so this is your homework. To get the value of q, you will get the value of q in coulombs. Okay, so please calculate this. Let us move to the next question now. Next question is two charge 5 coulomb and minus 4 coulomb. They are kept 5 meter apart. So data given is there are two charges. We can say Q1 and Q2. So Q1 is 5 coulomb and Q2 is minus 4 coulomb. They are kept at 5 meter apart. So we can say this is Q1, this is Q2, and the distance between them is 5 meter. Apart at points A and B respectively. So this is point A, this is point B. How much work will have to be done to move the charge A at A through a distance of 5 meter further away from point B along the line BA. So again we have to move this charge A by a distance of 5 meter again. Okay. So to find, we can say to find is work done, and work done is nothing but voltage multiplied by charge. Voltage multiplied by charge. Now which charge is to be moved? The charge which is present at position A, so we can say it is Q1. Okay, so what we have to calculate here, we'll be calculating voltage. Voltage formula is 1 upon 4 pi epsilon 0 Q divided by R. So which voltage you want to get? The Q1 divided by R1. Okay, so R1 is this distance, actually this voltage at this position. This is equal to, we can start solving the question. Voltage, it is equal to 9 into 10 raised to power 9 into the value of Q1. Q1 value is 5 divided by the distance. Distance again it is 5 meter. 5 will get cancelled. This is 9 into 10 raised to power 9 volts. Okay, W it is equal to voltage into charge. Voltage is 9 into 10 raised to power 9, and the charge is where is the charge? 5. So this is what 5 coulomb. So this will become 9 5 45. 45 into 10 raised to power 9 joules. This much is the amount of work done. 45 into 10 raised to power 9. Okay. Now, if suppose here it is written it is what 5 microcoulombs. So by that we have to substitute the value of micro. Micro means what 10 raised to power minus 6. So if it is written 10 raised to power minus 6, we have to write 10 raised to power minus 6. Such that it will become plus 9 minus 6. It is going to become plus 3. Again, this will be 5 into 10 raised to power minus 6. This is going to be plus 3. And the answer will be 45 into 10 raised to power minus 3. Plus 3 minus 6, it is going to be minus 3. If it is written here, microcoulomb. If it is coulomb, then the first answer is correct. Okay. So let us move to the next question. The next question is 4 charges plus 6 into 10 raised to power minus 8 coulomb each. So 4 charges are there. That means the data is Q1 it is equal to Q2, it is equal to Q3, it is equal to Q4, and all these charges it is 6 into 10 raised to power minus 8 coulombs. They are present at the corners of a square. So this is what a square is there. This is A, B, C, D is a square. Square means all sides are same of 3 centimeter each. So all are 3 centimeter. This again 3 centimeter. This again 3 centimeter. This again 3 centimeter. If you want to consider a diagonal, the diagonal can be calculated by using Pythagoras theorem. Okay, AB square plus BC square is equal to AC square. You will get it is 3 root 2 centimeter. Okay, if you want, you can calculate it. You will get 3 root 2 centimeter. Calculate the resultant force on each charge. Show in direction a diagram drawn to scale. So we have to show the direction also. So we will consider the total charge at position A first. So we'll be calculating the force due to this force on A because of charge D. We'll calculate. Then we'll calculate force on A because of charge C, and then we'll calculate force on A because of B. So we have to calculate all individually. So to find is total force acting at position A, suppose this we want to get. So the formula is magnitude of FA bar, it is equal to under root of result term FAB square plus FAC square plus FAD square. So this all term has to be considered. And what is the value of FAB? So I will write here. So value of FAB, it is equal to 1 upon 4 pi epsilon 0. Again K term is not there, we will not write that K value. QA QB divided by RAB square. Okay. Similarly, what will be the value of FAC? It will be equal to 1 upon 4 pi epsilon 0 K. K we will not write. QA QC divided by RAC square. Similarly, what is going to be the value of FAD it is equal to 1 upon 4 pi epsilon 0 QA QC divided by RAC square. So what is given in the data is the value of RA. RA value is equal to RAB. If you consider RAB is 3 centimeter. Next is RAC. RAC it is nothing but RAC if you consider AC it is 3 root 2 centimeter. Again, this is AD. AD means this will be A QA QD RA D square. RAD it is equal to 3 centimeter. Okay. So we have to substitute. The first we will calculate the individual values. First we will calculate FAB. Second we will calculate FAC. Third we will calculate FAD. And in the fourth term we will be calculating the total force FA, which is nothing but under root of FAB square plus FAC square plus FAD square. Okay. So this calculation part is homework. So please do this homework. Okay. Let us move to the next question now. So next question says electric field in the region is given by E bar, which is 5 k cap we can say. So ijk k term this represent what? Z axis. So electric field is there along Z axis. Calculate the electric flux through a square of sides. So square is there, that means all sides are same. This length is 10 centimeter. What will be the area? Area it is length square. That means 100 centimeter square is the area. The square in the following cases, the square is along xy plane and the square is along xz plane. And the third one is normal to the square makes an angle 45 degree with the z axis. So this is 45 degree. This makes an angle 45 degree with the z axis. Okay, so we'll write the data. What is the data here? The data here is E bar. What is the value of E bar? E bar it is 5 k cap Newton per coulomb. So k cap ijk, k cap is the term along z axis. So if you draw z axis like this, x axis is like this, y axis is like this. So the electric field is along z axis. That means along this axis the electric field is there. Now if suppose the square is along xy plane, that means the square is present like this along xy plane. So E bar it is perpendicular to xy plane. So to find, I can say here fluxes we want to get. So flux in the first case will be phi1 is equal to question mark. Flux in the second case phi2 is equal to question mark. Flux in the third case we can say phi3 it is equal to question mark. What is the formula of flux? The formula is phi is equal to E into A into cos theta. E into A into cos theta. Okay. Solution. So phi1 here it is PA and the angle is what? Angle is 90 degrees. So we can say theta 1 it is equal to 90 degrees. So cos 90 is what? 0. Cos 90 is 0. So this will be multiplied by 0. Phi 1 it is equal to 0. Weber. WB is the Weber is the unit of magnetic electric flux. Next is phi 2. Now phi 2 it is along xz plane. XZ plane means like this. This is what XZ plane. Now E bar and XZ plane are parallel to each other. So in this case theta 2 it is equal to 0 degree. So what is the value of phi 2? Phi 2 it is equal to EA cos 0. Cos 0 is what? 1. So E value is what? 5. A value is what? Area. So area it is what? Length it is this. Area it is this. So it should be there in meter square. So this is 100 into 10 raised to the power minus 4. So we say this is 10 raised to the power minus 2 meter square. This is the value of phi 2. Okay. This is the value of phi 2. Cos 0 is what? 1. So phi 2 value is known. Phi 3 now. Now this is written that it is making an angle 45 degrees. So directly theta 3 is given it is 45 degrees. This is EA cos 45. Cos 45 is 1 upon root 2. E value is 5. Area is 10 raised to the power minus 2. And this 1 upon root 2. Okay, so you have to solve this and get the value of phi 3. Okay, this is there in Webers. This will be there in Webers. Okay, so the solution is homework. Please solve this. Let us go to the next question now. The next question is 3 equal charges 10 into 10 raised to the power minus 8 coulomb respectively each located at the corners of a right angle whose sides are 15 centimeter, 20 centimeter, and 25 centimeter. So we are going to draw a right angle of hypotenuse will be greater. So this is 25 centimeter. This is going to be 20 centimeter, and suppose this is 15 centimeter. Find the force exerted on the charge located at 90 degrees. So there are charges present at the corners and all the charges are same. 10 into 10 raised to power minus 8, that means 10 raised to power minus 7. This is what 10 raised to power minus 7, because this 1 minus 8 is minus 7. So here 10 raised to power minus 7 coulomb is there, here 10 raised to power minus 7 coulomb is there, also here 10 raised to power minus 7 coulomb is there. Okay. Find the force exerted at 90 degrees. So here this force, here it is, suppose I will write the names. This is suppose A, B, and this is C. So this is for force B due to A. This will be FBA bar. This is going to be F on B because of C. So this will be FBC bar. Okay, and you want to get the total force. So total force is nothing but F. F will be nothing but under root of BA bar plus BC bar. So the data is Q1 it is equal to Q2, or we can say Q at A it is equal to Q at B, it is equal to Q at C. It is 10 raised to power minus 7 coulombs. Okay, to find is F at position C, this is B, sorry. F at position B is to be calculated. What is the formula? The formula is FB, it is equal to under root of FBC square plus FBA square. Okay. Next is FBC. What is the value of FBC? 1 upon 4 pi epsilon 0. K value is not given, will not write K. QBQC divided by RBC. What is the value of RBC? RBC. BC, it is what? 15 centimeter. So we can say RBC, it is equal to 15 centimeter, or we can say 0.15 meter. Next is FBA. FBA, it is equal to 1 upon 4 pi epsilon 0. QA divided by RBA square. So here square term is there. What is the value of RBA? RBA is equal to 20 centimeter. Okay. Then what is the value of force? Force will be equal to under root of FBC square plus FBA square. So first we will calculate this FBC, then calculate FBA, and then calculate the value of F. Okay. So this part is homework. Please do the calculations. Let us move to the next question now. Next question is a potential difference of 5000 volts. So data given is voltage, potential difference, voltage it is equal to 5000 volts is applied between the two parallel plates, which is at a distance of 5 centimeter. So the distance here it is 5 centimeter, we can say it is 5 into 10 raised to power minus 2 meters. A part of small drop having a charge of this much, the charge is given, charge it is equal to 9.6 into 10 raised to power minus 19 coulombs, falls between the plates. Find the electric field intensity between the plates. So to find first case is electric field intensity, that is the value of E is equal to question mark. The second is force on the oil drop. So we want to get the value of force F. What is the formula that we are going to use? So the very simple formula we will be using, that E is equal to voltage divided by distance. This is for first one, and for second case we will be using the formula of E, it is what? Force upon charge. So this implies the value of force that is equal to E into charge. So E we have already calculated in the first part. Okay. Let us do the solution. E is equal to V divided by D. So this is 5000 divided by D, which is 5 into 10 raised to the power minus 2. 5 will get cancelled and this is going to be 10 raised to power 5. This will be in volts per meter. This is the unit. The second is if it is equal to E. E it is what 10 raised to power 5. Q it is what 9.6 into 10 raised to power minus 19. So this value will become 9.6 into 10 raised to power minus 14 coulomb or Newton. So this much is the force. Okay. So all of you please take a note of this. Please pause the video and take a note of this. And I am moving to the next question. We have calculated P as well as F. So next question is to find the data is the first thing is data. Calculate the electric field. That means to find is what electric field E is equal to question mark. Due to a charge of this much, so Q it is equal to minus 8 into 10 raised to power minus 8 coulombs. At a distance of this much, so the distance D it is equal to 5 centimeter, we can say 5 into 10 raised to power minus 2 meter. So to find is what electric field. Electric field is given by actually this distance can be considered as R. 1 upon 4 pi epsilon 0 Q divided by R square. The formula is what Q divided by R square. So what is the value of E? E value is equal to, so if I write solution, 1 upon 4 pi epsilon 0 is 9 into 10 raised to power 9. The value of Q is minus 8 into 10 raised to power minus 8. Divided by R square. R square is what 5 into 10 raised to power minus 2 the whole square. Okay. So you have to solve this. So negative E we are getting, that means it is opposite to that of field. Okay. So 9 8 is 72. 10 raised to power minus 8 and plus 9 will give you 10 raised to power plus 1. Divided by 25 into 10 raised to power minus 4. Okay. So this is going to be, you have to solve this. Okay. So do these calculations. The unit is Newton per coulomb or voltage per meter. Okay. So I request you all to please do these calculations. This is homework part. So this is the topic which we have completed. We completed the topic electrostatics. Okay. Thank you so much all of you for paying attention. Best of luck. Goodbye.